Hey everybody, in this video we are going to go over section 1.8 which talks about solving polynomial and polynomial type equations, and specifically we're going to look at 4 different methods for solving quadratic equations. So I'm going to flip the screen around and we'll go ahead and get started. Alright, so like I said, in this section we're going to be looking at 4 different methods for solving quadratic equations. The first method is by using factoring. Let's get the pen working here. So we'll use factoring. The second method we'll look at is called the square root method. Then we'll look at a method that's called completing the square. And then the fourth one is the quadratic formula. All right, the only one of these that works every time is the quadratic formula. So if you're solving equations, solving quadratic equations, the quadratic formula works every time. It's not necessarily always the easiest way, but it does work every time. So a lot of times it'll be easier to use something like factoring or the square root method to solve a quadratic equation. But if you would like to, use this one method and it works every time, then by all means, you can use the quadratic formula on every single quadratic equation that you're trying to solve. All right, so let's get started and let's take a look at factoring. So the directions here just tell us to solve the quadratic equation by factoring. All right, so we have 17y plus 5y squared plus 40. All right, so in order for us to factor this, we need all the terms to be on one side, and we need it to be in descending order. So let's go ahead and move 40 over. And then while we're at it, we'll write this in descending order. So that's going to be 5y squared plus 17y minus 40 equals 0. All right, so now we have our equation written all on one side. We've got 0 on the other side. We've got it written in descending order. So we can go ahead and factor the left-hand side. So we'll just go over here off to the side and factor this. So 5y squared plus 17y minus 40. So we're just factoring the left-hand side. There's no common factors here, so we're going to go ahead and multiply a times c. We're using the AC method of factoring here. All right, so multiply a times c. So 5 times negative 40 is negative 200. And so we're looking for factors of negative 200 that are going to add to the middle term, which is negative 17. Let's see if I can fix this real quick. There we go. That'll work. Pairs of factors, sums of factors. All right, so things that multiply to give you 200, but add to give you 17. All right, so this is a large number to be looking for factor pairs or to be looking for factors of. I would not put one this large on the test, but you may see something like this on the homework. So some factors of 200, you could have, of course, like, negative 102. That's not going to add to 17. There's 50 times 4. That's the one we just did. Or excuse me, that was sort of similar to what we just did. 40 and 5, that's not going to work. 50 and 4 is not going to work. But 25 and 8, that'll work. It's got to be negative 200, so one of these has got to be negative. We want these to add to positive 17, so we need to make that 8 negative. So 25 minus 8 would be positive 17. All right, so that's my factor pair. I'm going to use those two numbers to split up the middle term. All right, so the middle term here gets split up into 25y minus 8y. Okay. Everything else just comes on down. I'm going to add a little plus in between there because I know that my 25y was positive. All right, so go ahead, group the first two, group the second two. This is 4 terms, so we know we're going to be factoring by grouping. Factor out of 5y. That's the common factor in these first 2 terms. That's going to leave us with a y plus 5. We want to have another y plus 5 over here, so we should pull out a negative 8. That'll leave us with y plus 5. Again, equal to 0. Now I'm going to pull out my common factor, which is y plus 5. All right, so pulling that out front. Leftover stuff is 5y minus 8 equals 0. Whoops, lost my little parentheses. There we go. Now just set each one of these equal to 0 individually. So y plus 5 equals 0. 5y minus 8 equals 0. Solve these. That's going to be y equals negative 5. And y equals, see, add 8 and then divide by 5. So that would be 8 divided by 5. And there's your 2 answers. You do not need to check your answers here. We'll see some equations that you do have to check your answers on, but this is not one of them. So there's our answer solved. We solved this one by factoring. All right, next we have one that's a little bit more simple. Here we have y squared minus 13y plus 42 equals 0. Everything's on one side. It's already written in descending order. So, and this is a pretty simple trinomial. It's got a leading coefficient of 1. So here we're just looking for things that multiply to give you 42, but add to negative 13. Can y'all think of those? That would be negative 7 and negative 6. So that's going to break down. Remember our little template. That's going to be right in your factors there, negative 7, negative 6. Split those up, set them both equal to 0. And there's your answers. So you can see how it was very easy to solve this by factoring here. And again, these are the two numbers that if you plug them into your original equation, they're going to make that equation true. All right, let's look at the square root method. The square root method of factoring is based off of this implication that I'm about to write. So it says, if a squared is equal to c, that implies, that's what this little symbol here means, that implies that a must be equal to plus or minus the square root of c. So basically to get a by itself, you can take the square root of both sides and you have to make sure to do the plus or minus of the number side. All right, so this is the rule for the square root method. Let's look at an example. Again, you may have to pause the video to write this stuff down, but I'm going to go ahead. All right, so directions here are a little bit longer. It says solve the quadratic equation using the square root method and write the solutions in radical form. That means they don't want you to write your answer as a decimal. They want exact answers, and it says we need to simplify our solutions. All right, so part A is 3x squared equals 36. All right, so you're trying to get the squared term by itself. Here it's the x squared, so divide by 3 so you can get that x squared by itself. 36 over 3 is what? That's 12. All right, so remember our rule. I'm going to write it out this first time, but after this I'll just, we'll skip right in this part. All right, so it says if a squared is equal to c, that implies that a must be equal to plus or minus the square root of c. Ow, hit my foot. All right, so here in our example, we can see that a matches up with x, c matches up with 12. So plugging it into our formula, we have x is equal to plus or minus the square root of 12. Now we can simplify this. This is in radical form, but it's not simplified yet. So remember how we simplify radicals. We think to ourselves, okay, what are two things that multiply to give you 12, one of which is a perfect square? That would be 4 and 3, right? So that would be 4 times 3. 4 times 3 is 12, and 4 is a perfect square. So you're going to go ahead and take the square root of 4. It's going to pop out front. All right, so that's going to be plus or minus 2 on the square root of 3. That's it. Again, if you're having to write your answers as a list, which you will see on some of these problems on the homework, you would write like 2 times the square root of 3, comma, negative 2 times the square root of 3. So that's written as a comma separated list. So again, that's a comma separated list. I think I spelled separated wrong, but it'll be okay. Yeah, that's supposed to be an A here. My bad. All right, so let's look at another example with the square root method. Here we have 8x plus 21 squared equals 27. All right, so we've got the squared term by itself. This entire thing is being squared. Now, if you did not want to use the square root method, what you would have to do is write this out as like 8x plus 21 times 8x plus 21. You have to FOIL that out. Then you'd have to eventually move that 27 over to the left-hand side and combine like terms. So this really is easier to use the square root method here. It works to your advantage. It's a little bit less work. So I said I wasn't going to write this out, but I think it is helpful. So here is our formula. It says that if a squared is equal to c, that implies that a must be equal to plus or minus the square root of c. All right, so here a matches up with 8x plus 21. C matches up with 27. So let's plug those in. We said that a is being replaced by 8x plus 21. C is getting replaced by 27. Oh, I missed my one here, 21. Sorry. Excuse me. All right, so let's go ahead. We're going to solve this for x, but let's go ahead and simplify this radical first. We know that 27 has a perfect square factor. It's 9 times 3. All right, so we could write that as 9 times 3. And then we're going to take the square root of 9. It's going to pop out front. All right, so that would leave us with, again, 8x plus 21 on the left, and plus or minus 3 times the square root of 3. All right, so now that we've got that simplified, let's go ahead and move the 21 over. So subtract 21, subtract 21. I'm going to write that in the front. So I have negative 21 plus or minus 3 times the square root of 3. All right, then divide both sides by 8. Okay, so we would have x equals negative 21 plus or minus 3 on the square root of 3 divided by 8. Now I see one more thing up top that we could do. We could factor out a negative 3. We could pull out a negative 3. That's going to change this to a positive 7. This plus will change to a minus. This minus will change to a plus. So that's still plus or minus. And then that's just the square root of 3. And then all that is over 8. All right, so this is technically the fully simplified answer. Again, that's a plus or minus in there. Got a little sideways. See if I can rewrite it a little neater. Okay. All right. So that was the square root method. Really useful for solving equations that are set up in this way where you have a squared term on one side and a number on the other side. All right, now let's look at what I would call like the most challenging method, which is completing the square. The people that this will be important for is people that are going on to take calculus. If you have to take calculus, you're going to need to know how to complete the square, so it's important that you pay attention to this method. if you know that you're not going on to take calculus, you do not need to use this method. On the problems where it tells you to use this method, you're welcome to use any other method. You could try to factor it. You could use the quadratic formula. But if you know you're going on to take calculus, I would suggest that you practice this method. All right, so take a second, pause the video, write down this method if if it applies to you. So it says step 1, write the equation ax squared plus bx plus c equals 0 in the form ax squared plus bx equals negative c. So basically move the constant term to the right-hand side. All right, step 2 is divide by a, which is the coefficient on your x squared term. All right, so dividing everything by a. Then divide your coefficient of x by 2, so take half of the middle term and then square it, and then add that number to both sides. The trinomial on the left is now a perfect square trinomial, and it can be factored easily. Okay. So let's look at an example using the completing the square method. All right, solve the quadratic equation by completing the square. All right, 3x squared minus 24x plus 15 equals 0. Now, when I look at this, the first thing I see is that we have a common factor here. 3 goes into 3, 3 goes into 24, and 3 goes into 15. So you can go ahead and pull out that 3, and that's going to make this problem a lot easier. So pulling out a 3, that leaves us with x squared minus 8x plus 5 equals 0. Now, I need to get rid of this 3, so I'm going to divide both sides by 3. That cancels. So I have x squared minus 8x plus 5 equals 0 over 3 is 0. All right, cool. So that was just a little, maybe a hint or a little trick or tip to look and see if you can factor out a common factor before you begin. Because look, that knocked all of our numbers down and made them much smaller. All right, so my first step in completing the square is to move the constant term to the right-hand side. All right, so I'm going to move the constant term over to the right-hand side. So I subtract 5 from both sides. Okay. Now, if you look at our second step, it says divide by a if a is not equal to 1, so that the coefficient of x squared is 1. So basically, if you have a coefficient on x squared, divide every term by it. We've already gotten rid of our coefficient on x squared, so we don't have to worry about this step. But if we had something, say, like a 2 here, we would go ahead and divide every term by 2. All right, now step 3 says divide the coefficient of x by 2, square the result, and add this to both sides. So here's our coefficient on x. I like to call this like the middle term. So go off to the side. Let's use a different color pen. This is like our scratch work. So take your middle term, take half of it, and then square it. All right, so negative 8 over 2 is negative 4. Negative 4 squared is 16. All right, so you're adding 16 to both sides. Okay, so we have x squared minus 8x plus 16 equals, let's see, negative 5 plus 16, that's 11. Okay. Now it says the left-hand side is now a perfect square trinomial. All right, so that means that it's going to be super easy to factor. You're looking for factors of 16 to add to negative 8. That, of course, is going to be 4 and 4. All right, so that's, excuse me, I said 4 and 4, but I meant to say negative 4 and negative 4. Those both multiply to give you positive 16 and add to negative 8. Another way we could write this left-hand side is x minus 4 squared. Now I can use the square root method to finish solving this. All right, so remember my square root method looks like this. If a squared is equal to c, that implies that a must be equal to plus or minus the square root of c. Right, so that means a is getting replaced by x plus 4, c gets replaced by 11. (11) is a prime number. It does not have any factors that are perfect squares. So all I need to do here is get x by itself. So I'm going to add 4 to both sides. I'm going to stick it in the front again. So I'm going to do 4 plus or minus the square root of 11. And that's it. I'm done. So that is completing the square. So basically you take something that's not a perfect square trinomial and you complete the other side so that it forms itself into a perfect square trinomial. So that's why it's called completing the square. All right, our last method, tried and true quadratic formula, works every time. So if you have a polynomial, or excuse me, a trinomial ax squared plus bx plus c equals 0, the quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Definitely something you want to write on your formula sheet if you don't have it memorized. All right, pause the video if you need to finish writing this down. I'm about to move forward. All right, so we have two equations that we're going to look at here. It says solve the quadratic equation by using the quadratic formula. All right, so in order for the quadratic formula to work, you need to have everything on the left-hand side. So we have 3x squared plus 4x equals 8x minus 5. So we're going to need to move this stuff over. Try that again. Get 0 on one side. All right, so that's 3x squared minus 4x plus 5 equals 0. Now I can go ahead and use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over, b squared minus 4ac all over 2a. All right, so in our problem, a is 3, b is negative 4, and c is 5. Okay, so let's plug those numbers in. So negative b, so it's negative 4, which is positive 4, plus or minus the square root of b squared, so that's negative 4 squared, minus 4 times a times c, so times 3 times 5, excuse me, all over 2 times a, so that's 2 times 3. All right, so I would highly suggest that you simplify inside of the radical first. Remember, that's called the radicand with a D. All right, so negative 4 squared is 16. All right, so that's, I don't have my document camera hooked up right now, so I can't show you guys my calculator, so I'm just going to write out what I'm doing. 16 minus 12 times 5 is 60. So 4 times 3 times 5 is 60. 2 times 3 is 6. All right, 16 minus 60 is negative 44. All over 6. All right, so let's try to think of some factors of 44, one of which is a perfect square. That would be 4 and 11, right? So that would be 4 plus or minus the square root of 4 times 11. Again, that's all over 6. Now go ahead and take the square root of 4. It's going to pop out front. All right, so that's going to become 4 plus or minus 2 times the square root of 11 all over 6. Got a common factor of 2 in the top, so pull that out. So that's Oh my gosh, I'm so sorry, you guys. That's supposed to be negative 44. Whoa, that was a close one. Let me back this up a little bit. This isn't wrong. I just don't have room to write in my negative, so I'm going to rewrite it. Sorry, you guys. I just realized that 16 minus 60 was supposed to be negative 44, not just 44. So that was my bad. It's not going to make a huge difference on our answer, but we are going to have to, you know, pull that I out front. All right, so we're going to say that that's negative 4 times 11 all over 6. So when we take the square root of negative 4, we know that's going to be 2i. That was from back in section 1.5. All over 6. Again, in the top, you have a common factor of 2. So pull out a 2. That leaves you with 2 plus or minus I times the square root of 11. All over 6. And then 2 over 6 reduces to 1 over 3. So that's going to just be 1, or you don't have to write it at all. You can just write 2 plus or minus I on the square root of 11 over 3. So again, what I just did, I said 2 over 6 reduces to 1 over 3. And that's it. That's my final answer. So totally fine to have complex numbers in your answer here. All right, let's look at one more. Here, I chose this one because it had that negative coefficient. We have negative 7y squared plus 7y plus 1 equals 0. Everything's on one side. We've got 0 on the other side, so we can jump straight to the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so here a is negative 7, b is 7, c is 1. All right, so x is equal to negative 7, negative b, that would be negative 7, plus or minus the square root of b squared, so that's 7 squared, minus 4 times a times c, so times negative 7 times 1, all over 2 times a, so that's 2 times negative 7. All right, so simplify the radicand first. 4 squared is 49. All right, so that's negative 7 plus or minus the square root of 49 minus, let's see, that's negative 28 over negative 14. Let's see, 14 minus negative 28 is 49 minus negative 28 is 77. Over negative 14. Let's see, factors of 77. Just checking on my calculator right now. I'm dividing it by some of my perfect squares, like 77 divided by 4. That doesn't come out to a whole number, so it's not one of its factors. 9 isn't. See, 77, 16. Nope. Definitely not 25, 36. No. All right, so 77 does not have any perfect square factors. So there's nothing you can do here, and you are done. I guess you could factor out a negative 1. I'm not sure if your homework wants you to do that, if they say that this is incorrect. You could pull a negative 1 out front. That would become 7. Again, this becomes a minus, this becomes a plus, so it's still plus or minus over negative 14. All right, so that just cancels off that negative. Negative 1 cancels with the negative here. And you're left with just 7 plus or minus square root of 77 over 14. Okay. All right, guys, that's everything for this video. If you have any questions about this video or about any of the methods of solving quadratic equations, please let me know. And I'll see you guys soon. Have a good day.